So we're starting a unit on probability. Originally it was going to be geometry, but we had to move some things around in our department. So we're starting probability now, and you have this form up here. You buy a packet of M&Ms that has 20 pieces in it. 10 pieces are red, 5 are blue, 3 are yellow, and 2 are brown. If you pull one out randomly, which color are you most likely to get? So this is the very first day of probability, so I'm not expecting every single kid to know what probability is. But the majority of kids are going to look at this and say, well, there's way more red M&Ms, so I should be more likely to get a red M&M. And that's just the very basic starting place for probability. Today we're going to do some probability vocabulary, and we're going to find the probability of some events in experiments. So, this is an experiment, spinning a spinner to see what color you land on. We're going to look at some definitions here. An experiment is a situation involving chance or probability that leads to results called outcomes. In the problem above, the experiment is spinning the spinner. Then we have a blank is a result of a single trial of an experiment. That would be an outcome. And we saw that right up here. An experiment involves results called outcomes, so an outcome is the result of a single trial of an experiment. The possible outcomes for the spinner experiment are landing on yellow, blue, green, or red. A blank is one or more outcomes of an experiment. That's an event. An event is one or more outcomes of an experiment. One event of this experiment is landing on blue. Now, an event is kind of like a rectangle. It's a broader category. So a square is always a rectangle, but a rectangle is not always a square. A thumb is always a finger, but a finger is not always a thumb. Likewise, an outcome is always an event, but an event is not always one outcome. It could be more than one outcome. And finally, probability is the measure of how likely an event is. Probability. So the probability in this experiment of landing on blue is 1/4, 1 out of 4. Because of the equal sized pieces, there are 4 of them and one of them is blue, 1 out of 4. And we get this formula down here, probability of an event. The probability of event A is the number of ways event A can occur over, or divided by, the total number of possible outcomes. So we have some experiments. And this is page 2 in the student's packet that they get. So we have this first experiment here where we have a spinner that is 4 equal parts, and the parts are colored yellow, blue, green, and red. After spinning the spinner, what is the probability of landing on each color? Well, we have our possible outcomes. Our outcomes are yellow, blue, green, and red. So the probability of landing on yellow is the number of ways you can land on yellow. Well, there's only one yellow piece, divided by the total number of colors, and there are 4 colors, so that's 1/4. Well, you might be able to guess all of these are the same, because there's the same amount of each color, and the total amount never changes, so there's always one piece of the given color, one piece of blue out of 4 total pieces, one piece of green out of 4 total pieces, and one piece of red out of 4 total pieces. In our second experiment, we're getting a little more complicated. Now we have a single 6-sided die. And so what's the probability of each outcome? And what is the probability of rolling an even number or of rolling an odd number? So first we're going to list the possible outcomes. And if you are quick, then you'll notice that they're kind of already down here. The outcomes are anything that could happen on a given trial. So when I roll the die, I could either get 1, 2, 3, 4, 5, or 6. So those are my possible outcomes. 1, 2, 3, 4, 5, and 6. And that means that the total number of sides of the die is 6 sides, and the probability that I'll land on 1 is 1. One of the sides has 1 on it. One of the sides has 2, so that's 1/6 chance it'll land on 2. There's 1 out of 6 chance it'll land on 3, and 4, and 5, and 6. So the outcomes all add up to the total when you put them together. There are 6 possible outcomes. Each of them, in this case, has a 1/6 probability of happening. But then we have an event. This is an event down here. Both of these are. These are outcomes. These are events. These are also events, but this can't be called an outcome, so we have to call it an event. So the probability of getting an even number. Well, even numbers are 2, 4, and 6, so that's 3 of them. There are 3 ways to roll an even number, and there are still 6 total sides. So 3 out of 6 of the sides are even. So that's our probability of rolling an even number, and 3 out of 6 is half the sides. So half the time, theoretically, you'll roll an even number. And for rolling an odd number, well, that's 1, 3, and 5. There are 3 odd numbers out of 6 sides, and that's also half the other half. So theoretically, half the time you'll roll odd numbers and half the time you'll roll even numbers. So this really illustrates the difference between an outcome and an event, because a single outcome is rolling a 1 or 2 or one of the other numbers, but rolling an even number is an event, and so is rolling an odd number, because it includes more than one outcome. So, of course, each outcome by itself is an event also. Can't forget that. So, in experiment 1, the probability of each outcome is always the same. So it's always 1/4 of a chance of landing on a given color on the spinner. And in experiment 2, it's always 1/6 of a chance of landing on a given number. But we're going to look at some where the outcomes have different probabilities. So, in the third experiment, a bucket contains 6 red, 5 green, 8 yellow, and 3 white rulers. If a single ruler is chosen at random from the, that should say bucket, what is the probability of choosing a red ruler, a green ruler, a yellow ruler, and a white ruler? Well, the possible outcomes of this experiment are, well, on a given pull, you're either going to get a red, a green, a yellow, or a white ruler. So those are our options: red, green, yellow, and white. So, the probability of getting a red ruler, well, first we need to know what's the total number of rulers, because it doesn't actually say in the problem, but that's something that we can figure out for ourselves. If there are 6 of one color, 5 of another, 8 of another, and 3 of another, we can just add that together to find out how many total rulers there are. So 6 and 5 makes 11, and 8 is 19, and 3 is 22. So that's 22 rulers. So our total is 22. And that's true on all of these, because we're still dealing with the total number of rulers. We're not taking any out or adding any in. So the probability of getting a red ruler is, well, there's 6 red rulers, so it'd be 6 out of 22. And because that's a fraction, we could simplify, divide by 2, and you get 3 out of 11. Green, there are 5 green rulers, so that's a 5 out of 22 probability. Yellow, there are 8 yellow, so that's 8 out of 22, and those are even, so we can divide by 2 and get 4 out of 11. And then white, 3 white rulers, so that's a 3 out of 22 probability. Okay, so are the outcomes of this experiment equally likely? Well, no. As a matter of fact, it's most likely you'll draw a yellow ruler than any other ruler, and it's the least likely one is a white ruler. So this is like the warm-up. in the warm-up there were different amounts of M&Ms, so you were more likely to draw a red one because there were more of them. Alright. Our fourth experiment, I believe, yeah, this is our final experiment, is choosing a number at random from 1 to 5. What is the probability of each outcome? What is the probability that the number chosen is even? And what is the probability that the number chosen is odd? So the possible outcomes of a number 1 through 5 are 1, 2, 3, 4, or 5. So there are 5 total numbers, and 1 is just one option out of the 5, 1 out of 5. 2 is another option out of the 5. You could get a 3. There's only 1 3. There's 1 4, and then there's 1 5. So there's a 1/5 chance of drawing any one number. But then our even numbers, well, how many even numbers are there? Well, there's 2 and 4, so there's 2 even numbers. That's 2 out of 5. And then there's odd numbers, 1, 3, and 5. So there's 3 odd numbers. So there's a 3 out of 5 chance of getting an odd number. And this is one where our outcomes all have the same probability. Outcomes are equally likely, but our events that we chose are not equally likely. So these are the events that comprise more than one outcome, and they are not equally likely. So just answer these questions here. Are the outcomes of this experiment equally likely? Well, yes. They all have a 1 out of 5 chance. The events, though, are not all equally likely. You have 2/5 for an even number, 3/5 for an odd number, and 1/5 for just a given number, because it's also an event. So the difference between an outcome and an event is that an outcome is only one possibility. So it's exactly one possibility that you could pick on a given trial. But an event can include multiple outcomes or possibilities. And it still says, it says could include, not that it has to include. So, like I said, an outcome is an event, but an event is bigger than just an outcome. Alright, so we actually have some practice online. Where did that window go? I forgot to open it this time. Alright, so our practice here is, it's in your kids' packets, but I didn't put it in the slide thing there because it's online and we can actually choose the answers. So in class, what I do is I ask the class the question, and I give them the answer choices as 1, 2, 3, and 4, and ask them to hold up the number of fingers that they think corresponds with the correct answer, so that everybody's answering at the same time, and I can see how much everybody as a whole gets the answer to the question. So, which of the following is an experiment? Is it tossing a coin, rolling a 6-sided die, choosing a marble from a jar, or all of the above? Well, we said an experiment is a situation where you have an outcome that is kind of by chance or probability. So when you toss a coin, you could get heads or tails. When you roll a 6-sided die, you could get any number 1 through 6. And when you choose a marble from a jar, you could get any of whatever colors are in the jar. So all of the above are true. For number 2, which of the following is an outcome? Rolling a pair of dice, landing on red, choosing 2 marbles from a jar, or none of the above? Well, rolling dice, that's an experiment. Choosing 2 marbles from a jar is also an experiment, but landing on red is an outcome to the experiment of spinning a spinner. Alright, number 3. Which of the following experiments does not have equally likely outcomes? Choose a number at random from 1 to 7, toss a coin, choose a letter at random from the word school, or none of the above. Well, if you choose a number at random from 1 to 7, you're going to get either 1, 2, 3, 4, 5, 6, or 7, and all of those are equally likely, a 1 out of 7 chance. If you toss a coin, you're going to get heads or tails, and the likelihood is about 50-50, 1 out of 2, that you'll land on heads or tails. But if you choose a letter at random from the word school, there's 1, 2, 3, 4, 5, 6 letters, and of those letters, you have 1 S, 1/6 probability of getting S, 1/6 for C, 1/6 for H, 1/6 for L, but 2 of the letters are O. So you have a 2/6 chance of getting O, or a 1/3 chance. So that one is not equally likely. And number 4, what is the probability of choosing a vowel from the alphabet? Well, first we have to remember that there are 26 letters in the alphabet, and that the vowels are A, E, I, O, and U. There's 5 of them, and sometimes Y, but for this we're just going to go with the ones that are always vowels. And so there are 5 vowels out of 26 letters, so that's a 5 out of 26 chance. And lastly, a number from 1 to 11 is chosen at random. What is the probability of choosing an odd number? So numbers 1 through 11, we have odd numbers 1, 3, 5, 7, 9, and 11. That's 6 out of 11 total numbers. And that is like our little last bit of review in class before I ask the students to say a little bit about probability in their own words and to write one thing that they learned about probability today that they didn't know before. And then they have their homework, which is there's an experiment. Jeremy has 8 bills in his wallet. 3 are $1 bills, 2 are $5 bills, 2 are $10 bills, and 1 is a $20 bill. If Jeremy pulls 1 out at random, what are the 4 possible outcomes? The possible outcomes are that he gets a $1 bill, a $5 bill, a $10 bill, or a $20 bill. I'm not going to answer all of these, but I did want to get to number 2, which is come up with an event for this experiment that is not also an outcome, meaning it's going to have more than one outcome as a part of the event. Just like with a die, we say what's the probability of getting an even number, and that's more than one outcome. It could be 2, 4, or 6. For something you could do that for this is that you could do anyway, so for this you could choose an event such as a bill that has a value of greater than $5 or a bill that has an even numbered value, just something that would have more than one outcome. And the rest of it should be fairly easy to solve on your own, I think.